Hello everyone, welcome to our mathematics channel 360 degree mathematics. Permutation series is going on. In the last videos we discussed different types of problems of permutations and board level type problem also being discussed. Now today's topic is competitive level problems discussion. The competitive level problems on permutations are different types. Today we will establish some special types on this part. Question number 1, if S equals to 1 into 1 factorial plus 2 into 2 factorial, this is 1 into 1 factorial plus 2 into 2 factorial plus 3 into 3 factorial plus dot dot n into n factorial. Then the answer becomes s plus 1 by n factorial belongs to integer, s plus 1 by n factorial does not belong to integer, s plus 1 by n factorial cannot be discussed, d none of these. All these four alternatives answers are given. Which one is correct? That is to be checked. Now the starting is this: S equals to whole series 1 into 1 factorial plus 2 into 2 factorial plus 3 into 3 factorial plus n into n factorial dot dot dot. This is k into k factorial form, because if k is 1 then k into k factorial, if k is 2 then 2k into k factorial, if k is 3 then k into k, and in this way we can generalize the term S equals to summation k1 to n k into k factorial. And in adjusting this term to our comfortable zone, k plus 1 minus 1 into k factorial, this minus 1 plus 1 will be cancelled and k into k factorial remains same. Now this becomes k plus 1 into k factorial minus 1 into k factorial, and it becomes k plus 1 factorial minus k factorial. K plus 1 factorial means under summation criteria n plus 1 factorial. K factorial means 1, that is, in left side we considered s equals to this result, then s plus 1, that is s plus 1, and in right side n plus 1 factorial. Now n plus 1 into n factorial, it becomes n plus 1 into n factorial. Hence s plus 1 by n factorial, which is in the question, s plus 1 by n factorial becomes n plus 1. N plus 1 means integer. Then the required answer is A. A answer was s plus 1 by n factorial belongs to integer, and this is the A. Answer is A. Now we discuss the second problem. In a certain test there are n questions. In this test 2 to the power n minus I students gave wrong answers to at least I questions, where I equals to 1, 2, 3 and dot 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 n. If the total number of wrong answers given is 2047, then n is equal to number A 10, number B 11, number C 12, number D 13. The solution is in this way. In the test there are n questions. The number of students answering exactly I means I greater than equal to 1 less than equal to n minus 1. Questions n minus 1. Questions wrongly is 2 to the power n minus I minus 2 to the power n minus I minus 1. The number of students answering all n questions wrongly is 2 to the power 0. All n questions wrongly is 2 to the power 0, because no question is correct. Hence the correct number is 0, that is 2 to the power 0. The total number of wrong answers is I into 2 to the power n minus I minus 2 to the power n minus I minus 1 plus 2 to the power plus n into 2 to the power 0 equals to 2047, because 2047 is given here. Now if I break it, then we will get this form: 2 to the power n minus 1, 2 to the power n minus 2, 2 to the power n minus 3 plus dot dot 2 to the power 0 equal 2047. And clearing this expression, we get 2 to the power n minus 1 equal to 2047. Hence 2 to the power n equal to 2048. That is 2 to the power n equals to 2 to the power 11 and n equals to 11. The n equals to 11 was the answer B. Here B is correct answer. Now we discuss a special type of problem. Type of letter envelope problem. If Pn is the number of ways in which n letters can be put in n corresponding envelopes such that no letters go to the correct envelope, means all letters will be put in wrong envelope, and this result will be Pn equals to n factorial 1 minus 1 by 1 factorial plus 1 by 2 factorial minus dot 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 plus minus 1 whole to the power n factorial. This is a special type. And this is formula. Now we will discuss this part with the help of an example. Now we establish a problem. We discuss a problem on the basis of letter envelope structure. If there are 6 letters L1, L2, L3, L4, L5, L6 and their corresponding 6 envelopes E1, E2, E3, E4, E5, E6 letters having odd value can be put into odd value envelopes and even value letters can be put into even value envelopes so that no letter go into the right envelopes. This is the structure. A letter 1, letter 2, letter 3, letter 4, letter 5, letter 6, envelope 1, envelope 2, envelope 3, envelope 4, envelope 5, envelope 6. Now we show that no letter go into the right envelopes. The number of arrangements will be equal to 4. This is the structure. And we will establish this structure by the use of formula. Letters are L1, L2, L3, L4, L5, L6. Envelopes are E1, E2, E3, E4, E5, E6. According to a formula, Pn equals to n factorial 1 minus 1 by 1 factorial plus 1 by 2 factorial dot dot minus 1 whole to the n factorial. Since there are 6 envelopes and 6 letters and 3 odds and 3 evens, and we arrange these 3 odd 3 events in this way: 3 factorial into 1 minus 1 by 1 factorial plus 1 by 2 factorial minus 1 by 3 factorial into 3 factorial 1 minus 1 by 1 factorial plus 1 by 2 factorial minus 1 by 3 factorial. And after calculation of these parts, we get, that is 4. The correct answer is correct ways of letter is 4 here. This is the proof. This is the application of that formula. Now we mention a special type of problem structure, that is exponent of prime p in factorial n. The language is exponent of prime p in factorial n. Let p be the prime number and n be the positive integer. Let ep n factorial denotes the exponent of the prime p in the positive integer n. Then ep n factorial equals to n by p plus n by p square plus, this is greatest integer, n by p cube and dot n by ps, where s is the largest positive integer such that p to the power s less than equal to n less than p to the power s plus 1. This is the special type, that is exponent of prime p in factorial n. Today we discuss letter envelope type, we discuss different competitive levels types and exponent of prime p in factorial n. This is all about today. Please keep watching to our channel for new videos and updates. Thank you all for watching this video.